Hello everyone, I am Dr. M.P. Deepak, Assistant Professor, Department of Mathematics, SNS College of Technology, Coimbatore. Today we are going to see on case study on Fourier transform. Fourier transform is nothing but it's a mathematical tool which changes the time domain to frequency domain. Time domain is nothing but changes over time. Frequency domain means the frequency which has examples like guitar, drums, the frequency which transforms the signals into wave. Now we are going to see some real life applications of Fourier transform in engineering field. Now going to see some real life applications of Fourier transforms in electrical and electronics engineering.
Hello everyone, and I am Salman, and I am here to give the real life application of Fourier transform in Jubilee. First of all, we use Fourier transform in signal analysis. We use this to study the frequency components of a signal. For example, in an oscilloscope or a spectrum analysis, we use Fourier transform to detect unwanted frequencies or harmonic in the electrical signals. And the other application is communication systems, that is for modulation and demodulation and signal transmission. In FM and AM modulation radio, the transmitted signal is analyzed and reconstructed using Fourier transform to recover the original message. And the other application is power system analysis, that is we use to detect harmonics and distortion in an electrical power. In power quality analysis, Fourier transforms help to identify harmonic and distortions caused by electronic devices like inverters or converters. And in audio signal processing, that we use to remove noise and improve sound quality. In mobile phones and hearing aids, Fourier transform helps separate speed signal from background noise. And in image processing, to enhance and reconstruct an image. For example, in an MRI machines, Fourier transforms converts signal and frequency data into detailed image of the human body. And in filter designs, to create a frequency selective circuits. In audio amplifiers, engineers use Fourier transform to design filters that pass desired frequency and block other frequencies. And in radar and sonar system, to predict objects and measure their distance or speed. For example, in an aircraft radar system, the received signal is analyzed using Fourier transform to locate and identify the object and its distance.
Next we are going to see some real life applications of Fourier transforms in mechanical engineering.
So Fourier transform in mechanical engineering. Vibration analysis of machine. When machines like motors, turbines, compressors and engines run, they generate vibrations. These vibrations are recorded as time domain signals like a wavegram. If a bearing in a motor is damaged, the frequency spectrum will show a peak at the bearing fault frequency. So next, noise and sound analysis. In automobiles, engineers try to reduce noise, vibration and harshness. Sound signals are analyzed using FFT, fast Fourier transform, to find which frequencies are out, where the noise is coming from, engine, gearbox, etc. Example, the car cabin noise test reveals that 200 Hz peak indicates engine firing frequency problem. So next, structural health monitoring. Bridges, aircraft, wings, pipelines and buildings vibrate at natural frequencies. Fourier transform helps detect change in these frequencies, which indicates cracks or damage. Example, if a bridge natural frequency decreases, it suggests leaking or car breakdown. Model analysis of mechanical structures. When designing frames, beams or machines components, engineers want to avoid resonance, dangerous vibrations. Using Fourier transform, they can identify the natural frequencies more safe. Example, designing a bike frame so that the engine vibration frequencies do not match the frame's natural frequencies.
Next we are going to see some real life applications of Fourier transform in electrical and communication engineering.
And today I am going to explain the real life application of Fourier transforms in ECE. Signal analysis. Purpose to study the frequency content of electrical signals. Example, engineers use Fourier transform to analyze audio, radio or sensor signals and identify noise or distortion. Modulation and demodulation. Purpose to convert signals for transmission and communication channels. Example, in AM, amplitude modulation and FM, frequency modulation. Fourier transform helps in understanding how carrier and message frequencies mix. Filter design. Purpose: to separate or remove unwanted frequency components like noise. Example: design low pass, high pass and hand pass filters using the frequency response obtained from Fourier transform. Image and signal compression. Purpose: to reduce data size for efficient storage or transmission. Example: Fourier based transforms like FT, FFT are used in JPEG image compression and MP3 audio compression. Spectrum estimation and channel characterization. Purpose: to understand how a communication channel affects a signal. Example: in wireless communication, FT helps determine multipath effects and handwidth usage.
Next we are going to see some real life applications of Fourier transforming civil engineering.
I'm Sanjeev and I'm going to explain about real life applications of Fourier transform in civil engineering. Single image processing, signal analysis, noise reduction, data compression. Telecommunication, essential for call and data transfer. Vibrations can be monitored on meters and they can be used on Fourier transform techniques. Structural response and seismic design, solving differential equation, and geotechnical and seismic analysis, and Fourier transform can also be used on signal processing.
Next we are going to see some real life applications in biomedical engineering.
These are the applications of Fourier transform on biomedical engineering. The Fourier transform is widely used in biomedical engineering to analyze signals and images. It converts complex time domain signals into frequency domain, working it easier to study their characteristics in medical imaging. It is essential for reconstructing MRI and CT scan images in ECG and EEG analysis. The Fourier transform helps detect heart or brain abnormalities by identifying their different frequency components to the signals. It is also used for image enhancement, noise reduction, and biomedical data compression. Moreover, techniques like Fourier transform, it is infrared selection, are used to study tissue composition and detect diseases. Thank you.
Finally, these are the applications and uses of Fourier transforms in engineering field. Thank you.